All right, man, let's get it. So, going to the parallelogram homework. Number one, trying to figure out x and y. Okay, so I'm thinking two parallel lines cut by a transversal. That's what I'm thinking. So notice that these two lines are parallel, right? Because it is a parallelogram. And the diagonal, right, creates alternate interior angles. So this is 20. Which makes a triangle. And I know that in a triangle, there's 180 degrees. So 130 plus 20 is 150. And it needs to be 180. So 180 minus 150, 30 degrees. So y is 30 degrees. X, right, opposite angles are going to be congruent. So x is 130. 130 degrees. It's pretty simple. Okay. All right, number two. X and y. So again, in a parallelogram, right, opposite sides are congruent. So it really doesn't matter where we start, to be quite honest. So 3x plus 8 is equal to 29. Solving for x, this is just an algebra 1 problem. So 3x is equal to 21. X is equal to 7. Five y is equal to 20. Y is equal to 4. Right? 5 times 4 is 20. So using the properties of parallelograms really comes in handy. What's going to make this difficult, right? The hardest part about geometry is the algebra, in my opinion. So if your algebra is not, like, if you ain't nice, then it's for sure going to be uphill, like almost the entire way. So here, I know that consecutive angles are going to be supplementary, meaning that they add up to 180. So the first thing I think is like, okay, this angle and this angle together have to add up to 180. So that means 3x plus the other angle, 4x plus 40. Together, these need to make 180. That's what that means. So just combining like terms, right? Basic arithmetic. 180 minus 40, 140. Right, and then 3 plus 4 is 7. That's kind of obvious. Divide both sides by 7. So 14, 7 goes in 14 twice with the 0. So x is equal to 20. Now it's not 20 degrees, right? Because x is equal to 20. Technically it'd be 60 degrees, but the problem's asking us for x. So you always want to be aware of that. Okay, so with that being said, 3 times 20 is 60. And this means that opposite angles are going to be congruent, right? These angles are going to be equal. The measure of the angles are going to be equal. So 60 is equal to 5y. Solving for y. Y is equal to 12. Because 5 times 12 is 60. Again, not 12 degrees, right? Y is equal to 12. The angle is 60 degrees. All right. Okay, number 4. We got X, Y, and Z. I mean, there's always going to be different ways of doing this. So it's whatever you recognize first. So a couple properties, if you can think back when we were in triangles. So really two ways. So the long way, you can figure out this angle, right? Subtracting 46 from 180. And then that number plus 35, again minus 180 will give you y. That's a way. I feel like a more efficient way would be that I know that y and 35 together, that must equal 46, right? That must equal 46. So y plus 35, this needs to equal 46. So minus 35 minus 35, y is equal to 11. So y is equal to 11. So this is 11. Which means, right, because these are parallel, which means this is 11. Which means that the whole thing is 46. Right? The whole thing is 46. We probably could have figured that out by using from the 46 that's down here. But either way, we're there now, right? Like, again, it's all about what you see first. Z, for the same reason that that's 11, this is going to be 35. Okay. So now let's figure out what X is. Well, I know that it is a triangle. Right here I see a triangle. And X plus 35 plus 11 needs to equal 180. So this is going to be what's going on. All right, so this is going to be 134. X is 134. We probably could have found that out in the very beginning, but you know, it's what it is, and we're there now. So all right, number 5. All right, so the arrows are indicating that the line segment, right? I wonder, is it saying that the whole diagonal is 2x plus 6? No, I think it's saying that this portion is 2x plus 6. And then the other portion is 40. So because I know that the diagonals bisect each other, like that's a hardcore fact, right? That the diagonals in a parallelogram bisect each other. That means this is equal to this. That's what that means. So 2x plus 6 is equal to 40. So 2x is equal to 36. X is equal to 18. For the same reason, if this is 16 and the other side is 2y minus 4, again, they bisect, so these are going to be congruent. So I can set the measures equal to each other. 2y minus 4, if I add 4, divide both sides by 2, y is equal to 10. All right, so this problem utilizes the fact that the diagonals bisect each other. That's what's happening here. All right, number 6. What do you think? Opposite sides are congruent. Okay. I think trying to solve for x first, right? 3x is equal to 6. Which means x is equal to 2, right? Because 3 times 2 is 6, so x is equal to 2. Plugging in 2 into the top value, this is going to be 4. So 4 is equal to y minus 1. Something minus 1 equals 4. Y is going to be 5. Right? Because if you add 1, y is equal to 5. So opposite sides are congruent in a parallelogram. Okay. The algebra starts to get heavy. First off, opposite angles are congruent. So 2x, 2 times something is 70. X is equal to 35. Right, x is equal to 35. Okay, if that's the case, when I plug in 35 here, 35 times 3, well, 35 times 2 is 70. 70 plus 35 is 105. Plus 5 is 110. So this is 110. You could do the math on that. That's 110. Opposite angles, I know, are congruent. Why did I use black? Right, these are the same. So this means that 110 is equal to x, which we know is 35, plus 3y. Okay, subtract 35 minus 35. We're going to get, so 105 minus 30, 75. Equals 3y. Divide both sides by 3. So this is going to be 25. Y is equal to 25. So that one's kind of right. You had to solve the easier ones first. Like, I don't think there was a way to solve for y. Like, it wouldn't be like, it wouldn't work out. You had to solve for x first. Okay. Number 8. What's going on here? So I think because the diagonals bisect each other, right? That's key here. These are going to be congruent. These are going to be congruent. So looking at the ones that have solvable numbers, right? 12 and 3x. 12 equals 3x. I think that's the best. That's where I would start. Otherwise, if you started the other way, right? Like let's say you didn't want to do that and you wanted to do 5y is equal to x plus y. Okay, well, you have 2 variables. It ain't going to happen, bro. So you need just one variable. So x is going to be equal to 4. Now that I have x is equal to 4, I can substitute that here. Right? So then 5y is equal to 4 plus y. This is doable. Minus y, 4y is equal to 4. 4 times something is 4. Y is equal to 1. Y is equal to 1. Okay. All right. So the given angles, we're looking for x and y. So right away, it's a parallelogram for sure. Like, all these are parallelograms. That's the name of the lesson. So alternate interior angles are congruent. alternate interior angles are congruent. So this means that 2x plus 3 is equal to 3x minus 7. Now you can actually just forget about this parallelogram business. This is just an algebra problem. So I'm going to combine like terms. Subtract 2x from both sides. I'm going to add 7 to both sides. So 3 plus 7 is 10. 3 minus 2 is 1. So x is equal to 10. And to figure out y, well, opposite sides are congruent. So 1 plus y is equal to y minus 1. All right, I'm adding y to both sides. Oh no, what's going to happen here? Do you see it? I feel like there's a mistake. Okay. This is going to be 1 plus 2y is equal to 1. Y has to be 0 in this case. I don't like that. I don't like that. 2y is equal to 0. Y is equal to 0. Well, hold on, wait a second. Because I'm thinking that a length can't be 0. We're not figuring length, we're figuring out y. Right? Y could definitely be 0. So if y is 0, this side length is 1. So I'm cool with that. Y is equal to 0. So sometimes you gotta remember what you're even solving for. Remember what you're even solving for. It's good to be logical, but sometimes you gotta keep in mind what you're solving for. So y is equal to 0. Okay. Same kind of problem. Same, like it's almost identical, right? Except we're just dealing with sides. Opposite sides are definitely congruent. So 2x plus y is equal to 6. Okay, this is kind of interesting. Okay, I mentioned we have two variables. So my instinct is to solve for y. This is just solve for y. So y is equal to 6 minus 2x. I'm gonna get y by itself. Only because like I'm already thinking ahead. What I'm thinking is that 4x plus y is equal to 8. And if I solve this for y is equal to 8 minus 4x. So now I have, right, y is equal to x minus 4x. Y is equal to 6 minus 2x. Because they're both equal to y, therefore they're equal to each other. So 6 minus 2x is equal to 8 minus 4x. Now, we've completely eliminated the y's, so we're definitely getting better here. So if I add 2x to both sides and subtract 8, left-hand side I'm going to get negative 2. Right-hand side I'm going to get negative 2x. So x is equal to positive 1. X is equal to positive 1. And now if I just take that x and substitute it into any one of these x's, it doesn't matter which one, right? If I go right here, if I let that be 1, so 6 minus, well, 2 times 1 is 2, so 6 minus 2 is 4. Even if you did it in the other side, right, it would still be 4 times 1 is 4. 8 minus 4 is 4. So y is definitely 4. That one was tricky. So it can be solved when you have two variables, But it just so happened in this case, we had two things with two variables, two sides with two variables. So if you isolate one of the variables and then set them equal to each other. Okay, first page is down. Let's go. All right, number 11. Same idea. Same idea. So it's just different numbers. Different numbers. Feel free to pause the video. But 2x minus y is equal to 3. I can move some things around. So I'm actually going to add y to both sides because I don't want y to be negative. And then I'm going to subtract 3 to both sides. So 2x minus 3 is equal to y. And then, so I'm going to put a burner of this on the back burner. Looking at the other side, 5y or 5x plus y is equal to 18. Y is equal to 18 minus 5y. I just subtracted 5x from both sides. So now I have two things that are both equal to y. Therefore, I can set them equal to each other. So 2x minus 3 is equal to 18 minus 5x. Combining like terms, if I add 5x to both sides, this is 7x. Add 3. That's going to be 8, 9, 10, 11, 21. Divide both sides by 7. X is equal to 3. Again, plugging into 3 into one of these. I'm going to do the one with smaller numbers because why not? 2 times 3 is 3. No, 2 times 3 is 6. 6 minus 3 is 3. So y is 3 in this case. Y is 3. Okay, let's go. What kind of angles are these? The consecutive. And consecutive angles are what? Supplementary. They add up to 180. They add up to 180. So this is going to mean that 6x plus y plus 3x minus y equals 180. Okay, combining some like terms here, we're going to get 9x, y minus y, that's nice, 0, which is equal to 180. Divide both sides by 9. X is equal to 20. Right, 180 divided by 9. 9 goes into 18 twice with a 0. So X is equal to 20. So let's see. Solving for that, can we figure out what y is? Man, I feel like y could be anything. Right, because if I plug in 20 into x, this is going to mean or what is this? This is going to, yeah, because y could be anything. Y could be anything. Well, it can't be anything. It could be something, right? Like, because it's still a degree. If I plug in 20 to this is going to be 6 times 20 is what? 120. 120 plus y. And this is going to be 60. 246. Okay. So y, I mean, I'm just, you know, I don't know what the key says, but logically, right, y would have to be smaller than 60. Y has to be smaller, right? Y can't be bigger than 60 because then you'd have a negative angle. I wonder what the key says. What number is this? 12. Hey, look at that. Okay, I was correct. So in this particular case, right, because we know what x is, we have 60 minus y, right? If y, think about it, if y is 61, 60 minus 61 would be -1. You have a negative angle, which we don't deal with that in geometry, or at least right now we don't deal with that. So that means that y has to be any number smaller than 60. Right? It can't be 60, right? If 60 minus 60 would be 0. So you can't have a 0 angle in a shape. So it has to be bigger. Or it has to be smaller than 60. But it needs to be bigger than 0. That's the kicker. So any number in between 0 and 60. That's kind of interesting. Okay. Okay, a little semi-word problem. In a parallelogram ABCD, the measure of angle A is 4x, B 10x plus 40, C 8x minus 40, and D 20x minus 60. Let's find each of them. All right, bet. Check it out. Let's draw a picture, because drawing a picture is what we do. Here's my two sets of parallel lines. So this is A, B, C, and D. Is it pictorially correct? You know, I don't know. But it doesn't change the fact that opposite sides are going to be congruent, right? Opposite angles are going to be congruent. So if A is 4x, C is going to be 8x minus 40. Now, it's understood, right, that you name shapes by its vertices. So you just start at one vertice and you go around. Does it matter that you go clockwise or counterclockwise? No, I don't think it does. So A, B, C, D, right? Going around this way, A, B, C, and then D. So I know that A and C are going to be equal. That's what I'm getting at here. So 4x is equal to 8x minus 40. So solving for this, for x first, I'm going to add 40 to both sides, subtract 4x from both sides. So 40 is equal to 4x. Divide both sides by 4. X is equal to 10. X is equal to 10. So that means, plugging that value back in, A is going to be 40. Since opposite angles are congruent, C is going to be 40 degrees, right? Degrees. And it is a quadrilateral. So I know that, I mean, there's nothing wrong with taking B and D and setting them equal to each other. By all means, be my guest. But like, let's just think of the properties, right? It's the reason why we study the properties is to make it efficient. I mean, technically, we would have been at the answer if I'd stopped talking. But I'm trying to explain what's going on. So if this is 40 and this is 40, 360 degrees in a quadrilateral. So that means 360 minus 80, right? 280. These together must be 280, and they're congruent. So that means 280 divided by 2, which is 140. So B and D are both 140. Could we verify that? Yeah, sure. You could pause the video and verify it. technically we could have just plugged in 40 there, right? But again, it's all relative to what you see first. That's what I saw first. So okay. Parallelogram 14, parallelogram RSTV. Diagonals RT and VS intersect at Q. Okay, get the parallelogram going. So parallelogram, they're parallel, that's parallel. It's supposed to connect, so you can use your imagination. So here's a diagonal. Here's a diagonal. We know that they intersect at Q. And this is going to be R, S, T, V. Diagonals intersect at Q. So RQ, 5x plus 1. TQ, 3x plus 15. So we know that the diagonals bisect each other, right? So these are going to be congruent, and these are going to be congruent. So 5x plus 1 is equal to 3x plus 15, right? And this is good old algebra 1. Solving for one variable. Combining like terms, 2x minus 1, 14. Divide both sides by 2, x is equal to 7. So that means when I take 7, right, because we're looking for segments QT and RT. So if I take 7 and plug it back in, 35 plus 1 is 36. So RT is 36. I know that the diagonals bisect each other, so the other one has to be 36. Could I plug it in? Sure, I could. 21 plus 15 is 36. Okay. Fitting 15. WXYZ is a rhombus. All right, so now it's very specific, right? Because it's a rhombus. Like it's more than just a parallelogram. It's a rhombus. Right, it's for sure, right? Going down like the tiers of things, right? It's a quadrilateral, it has 4 sides. It's a parallelogram, but it's a rhombus. Like it's very specific. So what does that even mean? That means that all the sides are going to be congruent, right? It's basically a square that's linked, right? Like it's linked to the left or to the right, however you want to look at this thing. So it's just tilted. It's a square that's tilted. I know that the diagonals bisect each angle. And they're perpendicular. So that's just properties off the top of my head. All right. So now let's see. What's it saying? WX is 4. Okay. So if this is 4, they're all 4. All sides. So XY is going to be 4. So let's see. What else? What else? WXY. So WXY. Okay. So this whole angle here is 60. The whole angle is 60. So because the diagonal bisects the angle, cuts into 2 equal parts, each of these are going to be 30. So right away, we know that 3 is 30 degrees. Okay, if x is 60, that implies that z is 60. So together they equal 120. Why is that important? Because quadrilateral has 360 degrees. So w and y together must equal 360 minus 120, right? Because this is 60, this is 60. Together they're 120. All together needs to be 360. So 240. So w and y combined must be 240. if you split that in half, right? Divide that by 2, W has to be 120. Therefore, Y has to be 120. Because the diagonal bisects each of those, that means this is going to be 60. And that's going to be 60. So 1 is going to be 60. 2 is going to be 60. WOZ. WOZ. Measure of WOZ, which is basically angle 4. That's 90, right? Because they're perpendicular. And ZWX. ZWX. Okay, that's just W. That's just 120. ZWX. 120. Okay. That one wasn't so bad. That seemed more complicated than what it was. But having a good understanding of, right, words mean things, right? The words just aren't here to make the page look pretty. Like when they tell you it's a rhombus, that's math for all sides are equal, the diagonals bisect the angles, and they meet at a perpendicular intersection. That's what that means. So, gotta speak the lingo. All right, 16. We're almost there. ABCD is a parallelogram. Okay, so now they're telling us, right, so strictly opposite sides are going to be congruent. That's what parallelogram translates to. And that the diagonals bisect each other. Right. Parallelogram is math for opposite angles are congruent and the diagonals bisect each other. Okay. So we need to figure out AR is 2x plus 3. So 2x plus 3. That's AR. RC is 35. So right there, the 4 tick marks, they're equal to each other. 2x plus 3 is equal to 35. So minus 3, this is 2x, this is 32. Divide both sides by 2. X is equal to 16. X is equal to 16. What else does it say? Switch the colors. So BR, so this guy 4y minus 10. BD is 180. Again, those are equal to each other. So 4y minus 10 is equal to 180. So if I add 10, 4y is equal to 190. 190 divided by 4. So this is going to be, well, it's half of 190. Half of 100 is 50. Half of 90 is 45. So 95. Y is equal to 95 divided by 2. 95 divided by 2. It's going to be, so 96 would be 48. 47.5. With this whole time without running into a decimal. Let's just double check the math on everything. So 2x plus 3, 35. We're good. So BR is 4y minus 10. 4y minus 10. Oh, I see what I did wrong. BD, the whole thing is 180. The whole thing is 180. So it's a good teachable moment here. So BR is just half of the segment. So I got to double that. We need to double the 4y minus 10. So that means 2 times 4y minus 10. Or 4y minus 10 plus 4y minus 10 would be 8y minus 20. And this needs to equal 180. Okay, add 20 to both sides. So 8y is equal to 200. This looks a little bit better. Divide both sides by 8. So y is equal to, 100 over 4, 50 over 2, 25. So y is equal to 25. Got to be able to catch the mistakes. Got to be able to catch the mistakes. Okay. 17. Okay, this one's kind of... All right, 17. LMON is a rectangle. All right, so just right there, what's that mean? It's a rectangle. It means that the opposite sides are going to be congruent and parallel. And it means that the diagonals are congruent, right? The whole diagonal. So NM, line segment NM, is congruent to line segment LO. That's what that means. And that the measurements are equal. Right? The measurements are equal. So let's see what they tell us. LM, so what is that? That's this side. This is 24. MN, that's a diagonal, is 30. So MN is 30. So 30. And the measure of angle 1 is 50. 50 degrees. Okay. Let's think about, or what do we want to solve for first? Okay, just what jumps out at me is that because this is a right angle, right, a rectangle has 4 right angles. That means this has to be 40. 2 has to be 40. 40 degrees. 3 has to be 40 because of alternate interior, right? Because these are parallel and alternate interior. So 3 is going to be 40. Which means that we figure out 4. Sure. So this is going to be 50. Because of the symmetry of this thing, this is going to be 50. And this is going to be 40. So here, right, there is a triangle. So 50 and 50 is 100. So 4 has to be 80. 4 has to be 80. So I think that takes care of all. Oh, no, we have one more. LXM. What is LXM? Okay, so that's X basically, right? Because it's the middle one. So X here. So X is 100 because a straight line has to equal 180 degrees. So 100. degrees. Okay, so that takes care of all the angles. Let's look at the sides. So NO has to be, it has to be 24 as well, or ON has to be 24. LN, okay, we can come back to that one for just a second. No, we just do it right now. Okay, so here, look. So LN is this. How do we figure that out? We can use trig. I like the fact that it's a right triangle. Right, 24 and 30. So Pythagorean theorem, I'm always looking for it. So if we call this little a, so a squared plus b squared is equal to c squared. Now, chances are this is a Pythagorean triple. I don't have those memorized. So I'm just going to do the math. So 24 squared, do have my inspire out. 576. So a squared plus 576 is equal to 30. So 3 times 3 is 9. 2 zeros. So 900 minus 576 is equal to 3. So a squared is equal to 324. Is that a perfect square? That's the question. A it is. It's 18. So a is equal, right, because when you take the square root of both sides, a is equal to 18, which means ln is equal to 18. Okay. What's nx? Nx. Okay, so if... Okay, so they bisect each other, right? I guess I failed to mention that part in the beginning. They definitely bisect each other. Diagonals, that is. They bisect each other. So if it's 30, nx is going to be 15. OL, that's the other diagonal. It's 30 because the diagonals are congruent in a rectangle. So there it is. All right, number 18. Quadrilateral. Okay, so it's a four-sided shape. KASI. Is a rhombus. Okay, so now that's very specific. Right, what do we know about rhombuses? All sides are congruent. We know that they intersect at a right angle. So immediately 5 is 90. And then I know that all the angles are bisected. All right, so what are we trying to find? The measure of 1, so the measure of 1 is 3x plus 8. Measure of 2 is 11x minus 24. So I know that the diagonal bisects them, cuts them into two equal parts, therefore they are equal. So this is going to be 3x plus 8 is equal to 11x minus 24. So adding 24, 8 plus 24 is 32, minus 3x. 11 minus 3 is 8. Divide both sides by 8. X is equal to 4. X is equal to 4. Okay. That's not bad. Oh man, we have the last one? Yes, because I'm not gonna do the chart. Now the chart, I'll leave it up, but I'm not gonna do it. So this last one, quadrilateral KASI is a rhombus, so same properties I just mentioned. 1 is gonna be 3x plus 1. 3 is gonna be 7x minus 11. Okay, so it's kind of a little different. It's a little different. But since all sides are congruent because it's a rhombus, these are going to be congruent. These are going to be congruent. And this is a 90-degree angle. 90-degree angle. So in a triangle, so check it out. So here's my triangle. Triangles add up to 180. The degrees that add up to 180. So 90 plus, well, technically 3 and 2 have to add up. 3 and 2 have to add up to 90. Right? Because if this is 90, there's 180 degrees, so they have to add up to 90. So that means 7x minus 11 plus, all right, 2. 2 is going to be 3x plus 1 because the diagonals bisect. So 2 and 1 are the same degree. So plus 3x plus 1, this has to equal 90. Right? 3 and 2 together have to equal 90. Combining like terms, 10x minus 10 is equal to 90. Plus 10, 10x is equal to 100. X is equal to 10. X is equal to 10. Okay. There is a nice little chart here that I started filling out. You can feel free to see if you can test yourself, test your skills on this. But for the most part, that's it. All right. Good luck.